Hi, welcome to my video on graphing linear inequalities with a single variable. In this video, we're going to talk about graphing an inequality. The term, expression, equation, inequality with a single variable is linear if the degree or exponent of the variable is 1. So notice we have a 7x, that's a degree 1, so that's linear. That's a 1, so that's linear. And that's a 1 variable, x, and that's linear. Notice this is an inequality, and degree is 1. So that's a inequality, linear inequality. This is a linear equation. This is a linear expression. An expression is this is a term. Expression is made up of more than one term. So again, the idea of a linear is degree 1, but it's a degree 1, and we have a single variable. Just to mention, we could have x plus y equals 7. Notice this is a linear. That's the degree 1. That's the degree 1. The highest degree of any one term here, that's the degree of 0. So this is the degree of 1, but there's two variables. So we're only talking about a degree of 1 with a 1 exponent. So 1 exponent, 1 variable. Let's continue. Just to review, the number set is natural, then the symbol for natural is n, and the natural numbers are 1, 2, 3, 4, etc. Whole numbers is w, and the whole numbers start with 0 and the natural numbers. So the whole numbers has 0 and the naturals. Integers are the whole numbers, which is 0, 1, 2, 3, 4, and their opposites, which is -1, -2, -3, -4, So the integers are the whole numbers, or the natural numbers, and 0 and the opposites. Notice, again, remind you, 0 is neither negative nor positive. So, and these are -1, -2, -3, -4, etc. are the opposite of 1, 2, 3, 4. Okay, when graphing any number belonging to these sets of natural numbers, whole numbers, integers, a solid, S-O-L, a solid dot is used on the number line when we use any one of these sets. Let's practice. Graph each. Notice the set builder notation, the set of all x such that x is greater than 1 where x belongs to the naturals. So all the natural is only, 1, 2, 3, 4. So greater than 1, but not 1. So that means we have a 2, a 3, a 4, a 5, and we're going on, so we put 3 dots on the end. B, this is the set of all x such that x is less than or equal to 3, where x belongs to the whole numbers. So we have to go less than or equal to 3. So we have to have a 3 because it says equal to. Less than 3 is a 2, and a 1, and a 0. But we can't go -1 because the whole numbers are 0, 1, 2, 3, 4, etc. So we can only put dots on the 3, 2, 1, 0. C, the set of all x such that line is a such that x is greater than or equal to -4 where x belongs to the integers. So integers are, as we set up here, there's the integers, 1, 2, 3, 4, etc., 0, and they're negatives. So we have to start at -4. And we have to go greater. It says equal to, greater than, equal to. It's pointing to the right, so I start at -4 and go to the right. So -3, -2, -1, 0, 1, and we continue on, so I'll put 3 dots on the end. D, the set of all x such that x is less than 5, where x belongs to the natural numbers. So the natural numbers, we can't have 5, but we got to go less than. So it's a less than 5 is a 4, 3, 2, 1. And these numbers are less than 5, but we can't shade in 0, -1, -2, because they're not natural numbers. The natural numbers are only 1, 2, 3, 4, etc. Moving on. So practice. Practice means pause the video and shade in these. So take your time, draw a number line, and see if we're going to shade them in right. When you've got them all done, press play. Here we go. This is the set of all x. Notice x is indicating a single variable, so we talk about a number line. Less than or equal to 4 belong to the whole numbers. So equal to 4. Remember, it's the whole numbers, natural numbers, and integers are just a set of dots. So equal to 4 and less than. 4, 3, 2, 1, and the whole numbers also has a 0. But we can't go any further because the whole numbers don't have a -1 or -2. It's -3. This is the set of all x such that x is greater than -2, where x belongs to the integers. Greater than -2. We cannot shade in -2 because it didn't say equal to. So greater than is notice is pointing to the right. Notice this is pointing to the left, so I had to go this way. This is pointing to the right, so I can't do -2. So -1, 0, 1, 2, and it's integers, so I can keep on going. So I use 3 dots. Number 3, the set of all x such that x is less than 1, where x belongs to the integers. Less than 1. We can't say 1, but we got to go less than 1. So that's a 0, -1, -2, -3. And we can keep on going, so we'll use 3 dots on the left side. Notice this is pointing to the left, so we have to go to the left of the 1, but not allowed to have 1. Number 4, the set of all x such that x is greater than or equal to 2, where x belongs to the natural numbers. So we say equal to 2, because it's a natural number, is a dot. So it's equal to 2, and greater. Greater than is pointing, this is pointing to the right, so I got to go 3, 4, 5, and it continues on, so you use 3 dots. So notice when you're shading the integers, whole numbers, or natural numbers, you got to use dots. Let's continue. What about when graphing any number belonging to the set of real numbers? Real numbers are denoted by R. When you're graphing, shading is used to represent all the numbers. So remember, when we did the natural, whole, and integers, we did dots, because there's in natural, whole, and that we don't have. Just to explain, if you have the natural number of 1, 2, 3, 4, there's no numbers in between 1 and 2. So the natural numbers can only be dots. The whole numbers can only be dots because there's no numbers in between. The integers can only be dots because there's no numbers in between. But when we talk about the set of real numbers, so we got a 0, and we got a 1, and we got a 2, and a -1, etc. So we can have 0, 1, and 2, but in real numbers, we could have a half. We could have 2/3. We could have 1.7. So we could have numbers in between. We could have a negative, say 4/5, which is right somewhere, right, and divided into 5 pieces, around right there. Or we could have irrational numbers. So let's continue. Just explain the difference between the dots and the shading. So the set of real numbers consists of the set of rational numbers, which are fractions, and the irrational numbers, which are, you can't repeat. Rational numbers are repeating decimals, or terminating decimals. Irrational numbers are numbers like √2. You cannot, square root of 2 is not terminating or repeating. It just keeps going on and on and on. Or pi is an irrational number. So let's continue. Just explain the difference between natural, whole, and integers are dots. When we shade with the real numbers, when we graph with the real numbers, we have to do shading. Shading, because we have to represent all the numbers between the numbers. The graphing includes all the numbers when you're shading. So if we're going to do the number line, and we want to talk about 0, 1, and 2. So if we start right here and we go greater than, so if I say x is greater than 1, so we have to shade greater than 1. We can't do dots. So the shading on this number line is a heavy line shaded in. There it is, shaded. So that's what we mean by when we're going to shade with the real numbers, we have to, when we're going to graph with the real numbers, we have to do a solid shading. Let's continue. The number that starts the inequality can be included or not included. Like right here, ones, this is in terms of 1, so it's the 1 that starts it, either going right or left. If the symbol is, that's pointing to the right, greater than, or less than, that's pointing to the left, the number is not included and a hollow dot is used. I'll explain that down here. Here we go. Notice x is greater than 3. It has no equal sign, so the 2 has a hollow dot and shading to all numbers on the right of 3. So we have to start at 3. There's 3, but we can't put a dot for 3 because it didn't say equal to. So we have to put a hollow dot, make it big enough so people can see it. There it is, a hollow dot on the 3. And we have to shade to the right because it says greater than. So there it is. The shading. And I've shaded in heavier than this. So starting at 3, but 3 is not included. B, x is less than -1. Has no equal sign. So the -1 has a hollow dot and the shading to all numbers to the left of -1. So it has no equal sign, so the -1 has a hollow dot. The hollow means it's empty, means it's not included. There's a hollow dot. And we have the less than is going to the left, so we shade in the number line on the left. There it is, shaded in. And we make the arrow bigger. Notice there's no dots. In whole numbers, natural numbers, and integers, there's dots on the end. But when we're doing the rational numbers and irrational numbers, which are reals, when we're shading with the reals, we have to use the arrowhead. We don't use dots because the arrowhead indicates that it's all the numbers that keep going. And it's impossible to name all the numbers. So graphing the real numbers, we have to shade in. If the symbol is greater than or equal to, pointing to the right, or less than or equal to, the number is included. And the shading is the numbers, is including the number, and shading is to all numbers to the right or left. That's examples. So notice this is greater than or equal to, so that includes the number and all the numbers to the right. Less than or equal to includes the number and all numbers to the left. Example, x is greater than or equal to 2. So that means we have to have equal to 2. So 2 is solid, not. 2 is solid. Let's go back up here. Notice a hollow, not included. No equal sign. Not included. No equal sign. So we have to start with 2 and shade pointing to the right. So we have to go to the right. So we shade over here. Here we go. There's the shading. And an arrow. No dots. Dots is only when you do integers, whole numbers, and natural numbers. And B, x is less than or equal to 4. So that means because it's equal to, 4 is included. So we make it a solid dot. Like we do with integers, we have to make it a solid dot. And that's pointing to the left, so we go shade to the left. So there's the shading. I'm making sure that you see the shading. I'm shading it in, but if you're doing it with your own pencil or pen, you would pick it out very easy. It's because all this is dark. So notice equal to. The dot, 4 starts it, so 4 is solid, and you go to the left. 2 starts this inequality, so you make it a solid dot, and you go to the right. Let's continue. Examples. Let's do some more examples. Graph each. Notice this says the set of all x such that x is greater than 1 and x belongs to the reals. Reals means I have the shade for inequalities. 1 is not included, So 1 is hollow. 1 is not included. Hollow dot for 1, and it's pointing to the right, so we shade everything to the right. There it is. B, the set of all x such that x is less than or equal to 3 belonging to the reals. Real numbers is shading. So it's equal to 3. So solid dot. And pointing to the left. So I shade to the left. So there it is. C, the set of all x. Again, remind you, is x. X is a single variable, so that means that you're on the number line. If you had x and y right here, you would have a xy plane. Such that line is such that x is less than -4 belonging to the reals. Reals means shading. -4 is not included. So we got a hollow dot with a -4. There's the hollow dot. And pointing to the left, so we shade on the left. So it's not hard to do. Just got to remember, is the number that starts it included or not included? Equal signs means the number is included. If there's no equal sign, the number is not included. Very easy to do. Just keep practicing. D, the set of all x such that x is less than or equal to 2 belonging to the reals. Reals means shading. So we have to have 2 equal to. So it's equal to 2. And we shade to the left. There's going to the left of 2. 2 is included because it said equal to. And there it is right there. Practice means pause the video and work the 4 of these out and see if you're going to get them right. So take your time, write the numbers line down and shade them in. Here we go. The set of all x such that x is greater than 2 where x belongs to the real numbers. So real numbers means I has a hollow dot for the 2. There's a hollow dot. And we go to the right. Why to the right? Because that's pointing to the right. Again, we got real numbers as shading. Notice I got 2 in every one of these. So we got a 2, but this time the 2 is equal to, so the 2 is solid. And we're going to the right because it says greater. How do I know greater? Because it's pointing to the right. Greater is to the right. 2 is not included here. So 2 is hollow. There's a hollow dot. Real numbers mean shading, but I shade to the left because it's left. So there it is. Big arrow. No dots. Shade. And number 4 is set of all x such that x is less than or equal to 2. So that means 2 is included. And real numbers is shading, so I have to shade all the numbers to the left. So hopefully you can see what this is all about. And real numbers, repeat, real numbers is shading. And the equal sign says is included, so we got to put a solid dot. 2 is not included, so it's hollow. 2 is equal, so I got a solid dot. 2 here is not equal, so it's hollow. So there's a hollow dot going to the right. This is a solid dot going to the right. This is a hollow dot going to the left. This is a solid dot because it's equal sign going to the left. Practice means pause the video again and see if you can shade all 5 of these in correctly. Here we go. Set of all x such that x is less than 1 belonging to the integers. Oh, integers. Integers are dots. So 1 is not included. So I can't include 1. So I got to go less than 1. So integers are dots. 1 dot, 2 dots, 3 dots, and I'm going on, so I'll put 3 dots out here. When you're doing real numbers, you can shade them in, but so when you're using dots, you got to put 3 dots on the end if you go left or right. Number 2, set of all x such that x is greater than or equal to -3 belonging to the reals. Reals is shading, so I start at -3. Yep. There's a solid dot at -3. And greater than is to the right, so I have the shade to the right. Okay. And number 3, set of all x such that x is less than or equal to 5, we belong to the whole numbers. Whole numbers are dots. So 5 is included. And pointing to the left is less than. So whole numbers are dots. And I didn't write them all in. I could have put a 1 in, put a dot. I could put a 0 in, a dot. I could put a -1 in, but I just wrote so many. And this continues on, so I have 3 dots at the end. Number 4, set of all x such that x is less than 4, where x belongs to the real numbers. Real numbers is shading. So 4 is not included. So 4 is a hollow dot. There's the hollow dot. Pointing to the left, so I have to go to the left less than. Go in the direction that the arrow is pointing. Shade it to the left. And there's the shading. Notice in real numbers there's no dots like number 1 and number 3 because of integers and whole numbers. And number 5 is set of all x such that x is less than or equal to 3 belonging to the naturals. So the natural numbers are dots. So 3 is included. It's pointing to the left, so I have to go to the left. 2, 1, and we have to stop. There's only 3 of them because the natural numbers are what? 1, 2, 3, 4, 5, 6, and so on. So we include 3, 2, and 1, and that's it. Done. And page 5. Practice. Which one is correct for each? So practice means what? All this page, as you can see, has practice. So you can pause your video. If you had a blank sheet, you can draw the number lines and work these out. But we have no graphing, so these are just as, except down right here. So we just answer these questions. Which one is correct? I have these shaded. Notice the number line. I have dots, so dots means you got integers, whole numbers are naturals. So right away, since they're a set of dots, I can scratch out reals. Why? Because reals means shading. So that one is not right. Now, I have, it says x is greater than 0. Greater than 0 means I can't have 0. So this one is gone. So the answer is C. This is the whole numbers that start at 0 and go to the right. So there they are. So that's the one. Number 2. Notice I have a shading. As soon as I have a shading, I'd say, oh, I have reals. Yep. So I can't have integers because integers are dots. So right away, if you look at the set of numbers, dots or shading tells you which one to work out. So I'm looking at one of these two. This time, right here in B, I have x is greater than 2. Right here, I have x less than 2. Notice there's a hollow dot. A hollow dot means there's no equal sign. Well, that's true for both of these. But because that's going to the left, pointing to the left, the arrow has to go to the left, so the answer is C. This one is, if I had this one, I would be shading on this side because it's pointing to the right, greater than. Number 3. Again, we have dots. So real numbers is, nope, I don't have real numbers. I only got naturals, wholes, and integers. So these mean dots. So I have less than 3. 3 is not included. Good, 3 is not included here, here, or here. So if I have the natural numbers less than 3, but the natural numbers are what? 1, 2, 3, 4, etc. I have a 0, so it's not naturals, because natural numbers can't have a 0. Integers, if I go less than 3 with the integers, I can't have integers, sorry, this is whole, integers right here. When I look at this one, I was looking at that one just then. Integers, it can't be integers, because integers got negative numbers, so the answer got to be B. So this is less than 3 is 2, 1, 0, belonging to the whole numbers. B is the answer. Number 4 has a shading. So I'm talking about real numbers. Oh, all of them got real numbers, so they're all okay. Yep. If I had dots here, I would eliminate the real numbers, but because of shading, they're all okay so far. It starts at -1 and is going to the right. So starting at -1, solid dot. So that means that this one is out because greater than doesn't include -1. So this one is gone. So it's one of these two. So -1 is included, solid dot. -1 is included, solid dot. This one is greater than, pointing to the right. This one is going to the right, so the correct answer is A. This one is pointing to the left, that would have been over this way. So A is the answer. Practice means, again, pause the video and work these out. Let's see, which one or ones is not true? Now, notice this, be careful. Which one or ones? So that means there could be one right answer, it could be two right answers. There could be no right answers. You got to be careful. Not sometimes some teachers put none of them are true. So which ones are true? And they have let's say have an option E. Sometimes some teachers say none. Let's say I put none in here for a second. That means it's possibility that none of these will be true for this set of what I got done. So just be careful. Let's see what we have. Real numbers, dots. So real numbers is gone because I have dots. So it's either B, integers, or naturals. Now, because I got negatives, that means the natural numbers are gone because the natural numbers don't have any negatives or zero. So it's got to be one of these two. So what about the 2 less than or equal to? Yep, that could be true. What about less than 3? That one is true. So the integers less than 3 means 3 is not included. So if 3 is not included, I can't have the 2, 1, 0, etc. So that one is true. And equal to 2, right? Equal to 2, 2 is included, and it's going left. So there's two answers, excuse me, that's correct for this one. B and D are both true. And we practice further, pause the video, and shade these. Number 6, the set of all x such that x is greater than or equal to 2 3/4. When we graphed previous in this video, we did the integers and the whole numbers. So 2 3/4, there's 2, there's 3, 3/4 is in between, so there's a half. So we have to divide it into 4 pieces. So there's the 4 pieces. 1/4, 2/4, 3/4, 4/4. So 2 3/4 is right there. 4 divided in 4 pieces. And it's greater than, not equal to. So there's a hollow dot right on that one right there. A hollow dot. There's a 2 3/4 right there. And you're shading to the right. So there it is. And real numbers mean shade left or right or in between. So there's a hollow dot at 2 3/4 shading to the right. Number 7, we have a set of all x such that x is less than or equal to -5/3. Reals are shading. So -5/3 is a negative. 3 into 5 goes once, 2 left over. So it's a -2, -1 2/3. So -1 2/3, there's a -1, there's a -2. So that means it's divided into 3 pieces. So 1, here they are. So that's -1, that's 1/3, 2/3, 3/3. So -1 2/3, that number is included because it's equal sign. So there it is, right there, solid dot, because it says equal to. And less, pointing to the left, so it's less than. So, and I just did the rational numbers just to have a bit of fun on graphing a rational number or a real number, because it's fractions, you have to divide it up, but it's easy when you got a graph, 2, 3, 4, they're integers on the number line, but I just wanted to put a few of these in extra. So that brings us to the end of this video on graphing, etc., etc. If you like my video, click the like button, the subscribe button, notification bell, write a comment on my video if you're a subscriber, and visit my math website at mathfullyexplained.com, and there you'll find information on me, videos, and content. And that brings us to the end. Thank you very much. Hope you enjoyed learning how to graph the inequalities. Bye-bye.